सो हेलो नमस्कार टू द ऑल केमिस्ट्री लवर्स, डॉक्टर्स एंड इंजीनियर्स ऑफ द नियर फ्यूचर। मैं विजय कुमार सोनी आपका स्वागत करता हूं इन केमिस्ट्री वाला चैनल रिगार्डिंग टू योर वन एंड ओनली मिस्ट्री दैट इज द केमिस्ट्री। In previous video we have discussed about the just structural isomerism in deeply. What is the type of the what are the types of the structural isomerism? Now we have discussed just 5 questions in the previous video regarding to the calculation of the total isomer, which is very important for not only for 11th class but also 12th and for the competition also. Now the time to discuss about the sixth question that is very important. What is that? The sixth compound is you can take C4. This is the H8O2. This is the very important compound. This is for the carboxylic acid. Carboxylic acid. If anybody asks you what will be the total isomeric carboxylic acid, then these will be as follows. There are 4 carbon atoms, COOH. This is the CS3, this is the CS2, this is the CS2. Another is your isomer. This is the iso chain. On balancing here will CS3, H and CS3. For the C is your, we can take function group isomer. If anybody asks you total carboxylic isomer will be 2. Function group will be as a ester. So then ester is your CS3, CS2, COOCS3. Whenever this CS2 shifts over here, function group is same, but substituent is different. So that will be your metamer. So metamer will be what? This is the CS3, CO shifting of CS2 over here. This is the CS2 and CS3. The D, E is your, will shift another CS2. So that is the CO, OCS2, CS2 and CS3. This is the F isomer. HCO, this is the O, this is the normal chain, we'll change it in iso chain like this. So here will be 1, 2, 3, 4, 5 and 6 isomer as a total isomer. 6 isomer as a total isomer. And if anybody asks you how much will be the carboxylic acid, then 2, and how much metamer will be, it will be 4. If we'll go with the just name, then the name of these compounds are, you can say, this is the butanoic acid. This is the 1, 2, 3, 2-methyl propanoic acid. 2-methyl propanoic acid. This is the methyl propanoate. This is the ethyl ethanoate. This is the propyl methanoate, because methanoate is present at number 1 position, so need not to give the position. Here will isopropyl, you can see this propyl. Over the number 2 position there is methanoate, so propyl 2-methanoate. So the total isomer will be as a 6 isomer, and just 4 will be as a metamer, and just 2 will be as a carboxylic acid. Now the time to discuss about the next question, that is the C3H9N. This is the 7th question. C3H9N. This will be for the amine also. So first isomer is your normal, 1, 2, 3, CS3, CS2, CS2 and NS2. This is the B. Carbon chain will be as a isomer, as iso chain. So this is the CH, this is the NS2. Further no 2 degree, no 3 degree carbon chain. So it will be function group. Function group will be your 2 degree amine. We have discussed. So this is the 2 degree amine. Further it will be your 3 degree amine. So CS3N, CS3 and CS3. These are the 1, 2, 3 and 4 isomer. If we'll go with them, then this is the 2 degree amine. This is the 3 degree amine. This is your 1 degree amine. This is your again 1 degree amine as a isomer. If we'll go with the name will be as follows. This is your propane amine. Propane amine, because of amine is present at number 1 position, so it's need not to give the position. But if this is as follows, then it is required to give the position, because of here is the just both are this is the complexion. So the name of compound will be propane 2-amine. For this is the longer chain will be as a amine. So this will be N-methyl ethane amine. This is your NN dimethyl methane amine. So these are the isomers regarding to the C3H9N. If anybody asks you total isomer, then total isomers will be your 1, 2, 3 and 4. And if anybody asks you just a total metamer, then it will be 1. Total just a function group, then it will be 1, 2 and 3 as a 1 degree, 2 degree and 3 degree amine. This was about the 7th question. Now the time to discuss about the 8th question. What is that? This is the 8th question. Now the time to discuss about the C4H9. This is the C4H11N. Again this is the amine. Again this is the amine. We'll take the total isomer for the C4H11N. So this is the first of all, A is your normal chain, CS3, CS2, CS2, this is the CS2 and NS2, 1, 2, 3, 4 carbon atom. This is the iso, CS3, CH, CS3. This is the CH2 and NS2. Again 1, 2, 3, 4 carbon. This is the 3 degree carbon chain also, CS3. This is the CS3 and NS2. It will be further isomer also, but see these two questions, one of the C4H8O2 and another C3H9N. If the fourth isomer C, third isomer is not visible, then I am going to erase it from here. We will take in the next slide. See the matter. So now the time to discuss about the further for the C4H11N. This is the as follows. So the third isomer for C4H11N will be C is your, this is the 3 degree carbon chain and this is the NH2. This was about the chain. We can take regarding to chain another is your 2 degree secondary, because of 4 carbon atom it will be 4 isomer. That's why 1, 2, 3 and 4 isomer. As a 1 degree amine it will be 4 isomer. This is the 1 degree amine. This is your 2 degree amine. You can say it is 1 degree amine but position isomer. NS2 is present, so it will be 1 degree amine. This is your 1 degree amine and this is also 1 degree amine. Further, we'll go with the function group. So E isomer is your 1. This is the NH, CS2, CS2 and CS3. Further metamer, function group is same with the same substituent, but it will be changed in this kind of the substituent. as a isopropyl. So this is the F isomer. In G isomer, we can change again another CS2 over here. So CS3, CS2NH, CS2 and CS3. This was about the function group as a 2 degree amine, 2 degree amine and 2 degree amine. 2 degree amine. This is again your 2 degree amine and this is your 2 degree amine. Now the time to discuss about the 3 degree amine, that is the GH isomer, CS3N. This is the CS3. This is the CS2 and CS3. This was about the 3 degree amine. So total isomer will be, this is the 1, 2, 3, 4, 5, 6, 7, 8. This is the 1, 2, 3, 4. This is the 5, 6, 7 and 8 isomer. So total isomer will be as a 8 isomer. And if anybody asks you how much as a 1 degree amine, then you will say 4 1 degree amine, as a 3 2 degree amine and as a 1 3 degree amine. If you go the name of compound, then this is called as butane amine. This is the butane amine or butane 1 amine. This is your, you can say 2 methyl propane amine. This is your 1 2 3. So 2 methyl, this is the propane 2 amine. This is the butane 2 amine. This is the N-methyl propane amine, because amine is present at the number 1 position, so need not to give the position, but here is position is required. So N-methyl propane 2 amine. This is the N-ethyl ethane amine. This is the N dimethyl ethane amine. So these are the just 8 isomers. Regarding to the just C4H11 and regarding to, you can see just 8 question also, 8 isomer. But it's not logically कि 8 question है तो 8 isomer होंगे. These are the 8 isomers. Now time to discuss about the 9th question. You can see the total isomer by pausing the video, because of I have to take a lot of questions in this kind of the video, and in the next video I'll take the next topic. So be with me. This is the 8th question. Now the 9th question will be your further. So this is the 9th question. 9th question. If we'll go with the 9th question, then what will be the isomer? We can take just your C3 H6Cl2. It's a best question. Cl2 means it is dihalide. If you will go with the type of the dihalide, then there are 3 types of the dihalide. Number 1. This is the number 1. This is the number 2 and this is the number 3. 3 types of the dihalide. Number 1 is your geminal. In short, it is called as Zem dihalide. This is called as vicinal or vis dihalide. This is the alpha omega dihalide. what is the basic thing regarding to these, then you can say these two halogen atom, both halogen atom, X atom means halogen atom, are present on same कार्बन एटम, एक ही कार्बन एटम पे प्रेजेंट हो, when both halogen atom X atom are present on neighboring carbon atom, and when both halogen atom are present, both halogen atom are present at first and last carbon of the chain. If we'll go with the just formula, then you can, this is the very important as I told you. So common formula for these gem dihalide will be your RCHX or X, and you can take another formula RCX, and this is the X and R. For vicinal you can take R, this is the CH X and CS2X. As a R you can take hydrogen and you can take alkyl group also. For this you can take CS2 whole N. Here is the X and here is the X, and N is equals to, at least there should be 3 carbon atoms. So this was about the just your dihalides. You can take the example also to learn about them. CS3, this is the CHCl and Cl. This is the another isomer CCl. This is the Cl and CS3. For this you can take CS2. This is the CS2, Br and Br. For this you can take CS2I and CS2C. This is the CS2 and this is the CS2I. This was about the just dihalides. I want to go with the just C3H6Cl2. So first is your geminal you can take. Both halogen atom will present at the number 1 carbon atom. Balancing will be as follows. Second isomer may use as a CS3CCl and ClCS3. Third isomer you can take just vicinal at the neighboring Cl and CS2, and this is the Cl as a position isomer also. Final is your alpha omega dihalide. So CS2 and CS2, this is the Cl. This is the gem dihalide. This is also gem dihalide. This is the vis dihalide, vicinal dihalide, and this is the alpha omega dihalide. If we go with the name, then we can take the name easily. What are they? This is the 1,1 dichloropropane. This is 2,2 dichloropropane. This is the 1,2 dichloropropane. This is the 1,3 dichloropropane. This was about the just C3H6Cl2. Now the time to discuss about the 10th question. This is very important. If we go with the just 10th question, then we can take C6H4Cl, C6H4Cl2. If it is aromatic compound, aromatic means having benzene ring, aromatic compound. So first of all, this is the C6H6 as a benzene. This is the another C6H6, another third C6H6. We have discussed in the previous video. It is a disubstituted benzene. So for the disubstituted benzene, there will 3 position isomer as a ortho, meta and para. So this will be the 3 isomer. There is the 3 isomer. three isomers as a position isomer. You can say ortho, meta, and para dichlorobenzene will be the name. So this one about the C6H4 Cl2 as a 10th compound. Now the time to discuss about the further 11th compound, that is too important. Now the importance is example wise increasing. This question is also important for the 12th standard, not only 11th but also for the 12th standard regarding to haloalkane and haloarine. So now I would like to go with the just 11th compound. So the 11th compound is your, you can say C7. This is the 11th compound C7H7Cl. It is also aromatic hydrocarbon because of there is more than 6 carbon atom. So these are the three position. Number one, I can say just CS3 and Cl. This is the 1, 2, 3, 4, 5, 6, 7 carbon. Hydrogen 3, 4, 5, 6, 7 hydrogen and 1 Cl. It is ortho. This is the meta 1, 3 position. And 1, 4 position is called as para position. 1, 2 position, as I told you, ortho. 1, 3 position is called as meta. 1, 4 position is called as para. Ortho is denoted by O, meta is denoted by M, and para is denoted by P. So these are the three position isomer, but it will be another side chain isomer also. This is your CS2Cl. You can count the chain 1, 2, 3, 4, 5, 6, 7 carbon, hydrogen 2, 3, 4, 5, 6, 7 hydrogen, and 1 chlorine. This is called as benzyl chloride. Benzyl chloride. So for this, it will be 4 isomer, total isomer. And anybody ask you just position isomer about the ortho meta para, then you will say just 3 position isomer. These are known as ortho, meta, and para chlorotoluene as the name of compound. Now the time to discuss about the further important compound, that is the 12th compound. What is that? That is your C7H8O. This is very important. Before taking C7H8O, we'll take another example. This is the C6H6O2. This is the very important compound. For this, it will again aromatic. So here is the C6H6. This is the C6H6. This is again your C6H6. First of all, position isomer. OH and OH ortho. You can count 6 carbon, 6 hydrogen and 2 oxygen. This is the meta and this is your para. Common name is called as catechol. Catechol, resorcinol, and this is the quinol. And IPC name is your benzene 1,2-diol, benzene 1,3-diol, and benzene 1,4-diol. You can go with the position 1, 2, 3, and 4. Benzene, this is your 1, 2, 1, 3, and 1, 4-diol as an alcohol. Now I would like to go with the just 13 question. This is the 12 question and this is the 13 question. This is too important, as I told you. C7H8O we can take. So this is the C7H8O. Again, this is the aromatic. So this is the C6H6, 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 3-position isomer. This is the CS3 and this is the OH. You can write it function group over here and the substituent over here at the ortho position. Count the carbon 1, 2, 3, 4, 5, 6, 7 carbon. Hydrogen 3, 4, 5, 6, 7, and this is the 8H8O. This is known as ortho, so that's why it is called as O-cresol. If it is present at number 1 and 3 position, this is called as M-cresol, and when it is present over 1 and 3 position, then it is called as P-cresol. These are the 3-position isomer. Function group will be as a one of the benzyl alcohol, CS2OH. This is your benzyl alcohol. And next is your 5th isomer. We can take ether, aromatic ether, as a anisole also. Anisole is the common name. Otherwise, it is called as methoxybenzene. So for this, it will be 5 isomer. 5 isomers. Now the time to discuss about the further question. That is you can take 14 question. It was 13. This is the 14 question. What is that? Regarding to 14 question, we'll take just an important example. That is your C7H8 we have taken. Now we'll go with just some of the example from the 11th class. 11th class के regarding बात करें, then we can take C4H8. This is the C4H8. Here is the CnH2n as a formula. Regarding to your alkene, so first isomer is your CS3, CS2, alkene means double bond. This is the CS2. Now I would like to go with the isochain. We can take this one as an isochain. You can count the carbon 1, 2, 3, 4 carbon, 3 to 5 and 3, 8 hydrogen, same iso. Now the time to discuss about the position. 1, 2, 3, 4 double bond is present at number 1 position. So its another position will be your 2 position. And if we'll go with the further example, then we have discussed alkene shows ring chain isomerism with just the cycloalkane. So one of the, we can take CS2, CS2, CS2 and CS2. This is the your cyclobutane, and we can take by the substituted cycloalkane also. So this is the CS2, CS2, this is the CH and this is the CS3. So 1, 2, 3, 4 carbon, 3, 4, 5, 6, 7, 8 hydrogen regarding to your C4H8. If we'll go with the name, then name is your but1ene. This is the but1ene. This is the 1, 2, 3, 2-methyl propene, 2-methyl propene. This is the but2ene. This is the cyclobutane, and this is your methyl cyclopropane. Methyl cyclopropane. So here total number of isomers will be 1, 2, 3, 4 and 5. Total isomer will be 5 isomer. This was about the C4H8 as a 14 question. Now we'll go with the 15 question, 11, 12, 13, 14. Now we'll go with the 15 question. What is that? Listen me carefully. We'll take one of the alkyne also. What is that? This is the C4H6. This is the 15 question. C4H6. Here is the formula. CnH2n minus 2. 4 to the 8 minus 2. It will be C4H6. This is your alkyne. First of all, you will go with the normal chain with the triple bond CH 3 to 5 and just 6. Now the time to discuss about the ISO. ISO is not possible. So for this it will be position. Position is at number 2 position. So this is the CS3 and this is the CS3. C. Except these further is not possible. So we can take just your ring chain isomer. And as you know that alkyne shows ring chain isomerism with the cycloalkene. So here is the 1, 2, 3 and 4 carbon atom. With the double bond you can keep anywhere. This is the CH, this is the CH and this is the CS2, 2 to 4 and just 2, 6 hydrogen. This is the cyclobutene. We can take another isomer if it is possible. Let's see. This is the cyclopropane. This is the CS3. 3 hydrogen. We require 6. So it will be your H2 and this is the double bond. This is the H and this is the all R valence is complete. So 3 and 3, 6. So it will be your methyl cyclopropene. This is the methyl cyclopropene because both are present at number 1 position, both double bond and substituent. We can take another isomer as follows. This is the C, this is the CH3, this is the CH, this is the C, here is your H, here is your H, here is your H. We can take double bond over here. 3, 4, 5, 6 hydrogen. We can say 1, 1, 2, 2 methyl cyclopropene also. So here will 1, 2, 3, 4 and 5 isomer. As a total isomer here will be 5 isomer. So this was about the just practice regarding to the structural isomerism. Do the rest question also and do these practice. Without doing this practice it is not possible to achieve the calculation of the total isomer. If you will do the paper pen work, then it will be very easy for you. So we will meet in the next video. पर्टिकुलर प्रैक्टिस करेंगे आप लोग और इसी तरीके से अपने डाउट्स वगैरह आप मुझसे शेयर करेंगे जो कि वीडियो के स्टार्टिंग में और लास्ट में कॉन्टैक्ट नंबर आपको गिवन है 9829198271. दिस इज वन एंड ओनली विजय कुमार सोनी रिगार्डिंग टू योर केमिस्ट्री वाला चैनल. इसी तरीके से अपना सब्सक्रिप्शन शेयरिंग कंटिन्यू रखिए क्योंकि आपका प्यार आपका सपोर्ट मिलना बहुत जरूरी है. एंड आई एम रेडी टू गिव यू अ लॉट ऑफ मैटर विच यू वांट. काइंडली मैसेज मी इन द जस्ट कमेंट बॉक्स and just through the WhatsApp number. Till then, shukriya, धन्यवाद.